All right. So cool. The recording started. Before we get into any of the new stuff, I do want to go over some review of Python level 1 and also just a reminder. I know Dirk and Evan, you're familiar with how things have went, but in general, in case anyone's listening to the recording, the class is going to follow the same structure as before. We have 8 of these lectures. Typically, I'm going to assign homework after each one. And if you have any questions, you can use the chat. I know that worked well last time. Or sometimes I'll ask you to unmute to answer questions if necessary. But otherwise, going over some of the topics of last level, we started with data types, like what are ints, what are booleans, what are strings, some of the different things that you can do with them, some of the different operators like adding, subtracting, but also like mod and floor division. We talked about lists, which were a little bit more of an advanced data type, where it's not just a single number or a single Boolean. It's like a bunch of them combined into one. And with lists, you can do things like index into them. So you can get a particular element out of it. You can store an element into whatever spot you want, as well as using slices. And the important thing to remember there was just that indices start at 0. So the first element is index 0, so on. And when you do slices, you go up to, but not including the last number. So if you take a slice from 1:5, you start at index 1 and you get whatever's there. So the start is inclusive. But for the end, you go up to 5, but not including, right? So that's the only thing tricky there. Towards the end, we talked about how to get user input. And so that was the input function, very easy in Python. You just get it and you store it into a variable. And we also talked about how if you want to use the input as like a number, for example, you had to do things, you had to convert it manually. And actually, later today, we're going to see something kind of building on top of that. Kind of a sneak peek is what happens if you try to convert something to a number, but it's not a number and you fail. What's going to happen and how to fix that. Then we did conditionals, if statements. So that allowed us for the first time really to do like to write a program that would do different things every time you run it, right? Conditionals were the if, else statements. And so in that way, you can have different like paths that your code can take. Sometimes it'll take the if, sometimes it'll take the else if, sometimes it'll take the else. And depending on which one it does, it runs different code, right? Before that, we had really no control over the flow of the program. It was just first line, second line, third line. But now the if statements gave us a little bit more flexibility. And finally, loops, that was our last class. They also controlled the flow of code. Instead of going 1, 2, 3, 4, it kind of repeated statements again and again. And we talked about for loops a lot, and I promised that we'd get to while loops now. So I will go over some loops a little bit more in depth. So a reminder, we did cover for loops. And so this was like an example of code that we went over last time in class number 8. And this was, you can probably tell from the print statement, this was an example of code to find the minimum element of a list, right? So you have a list of numbers and you want to find the smallest number. And how this worked, if you remember, you have this variable, the least here, and this variable stores kind of the smallest value that you've seen so far. It might not be the smallest yet, but once you go through the entire list, then you know for certain it's going to be the smallest in the whole list. Initially, it's just going to be the first element in the list because that's your best guess in a sense. And then here's the for loop that we talked about. And the syntax for the for loop was for blank in blank, where you have kind of a variable name and a collection, a list, a tuple, a string, a lot of things can be looped through. And what happens is you take every single element in your collection and you assign it to your variable one by one. So here the x is a list of numbers, 45, 23, so on. And every time this loop runs, n, our variable, is going to be assigned a different number one by one. And so the first time it's 45, the next time it's 23, then it's 76, so on and so on. So when you use n inside this loop, every time it's going to be different. Right? So here what it's saying is if n, the number that you're looking at, is smaller than the smallest so far, then you want to update your variable, right? If it's smaller than what you've seen so far, then you want to say the least equals n, right? You want to update it. And then essentially what this happens, how this works is when you go through your list, every time you find a smaller number, you keep track of it. And that way, you know, once you've looked through all the numbers, you know that you have the smallest element. And so this was our for loop. You kind of just say for a variable name in a list. And inside the loop, it just takes on every single value one by one. I also do have this. So let me zoom in a little bit. Oops, I have to click here. So here I have a list of different elements. And this list is a little bit weird because each element is a different data type, which is fine in Python. You can have a list that has an integer, as well as a string, as well as a Boolean, as well as a double. Right? It doesn't have to be the same type in Python. But here we have a list, and I want to print out every element one by one. And so if you just try to do the print statement on the whole collection, it's going to print out kind of the list format. But this isn't what I want. I wanted every element on a different line. And so I guess really quickly, does anyone want to give the answer of how to use a for loop to print out the elements one by one?
Like for every like space in like the list, like put it on a new line or something.
Oh, sure. Yeah, that could be one way to solve it. So I think the way I was going for was looping through the list itself instead of like the string. And so you can loop through the list element by element and then just print the element. So what I mean is like this. So you can say for X in my collection, and here X is just a variable name. Could have called it whatever I wanted. And then you just say print X, right? And so here, my collection is this list of 4 elements. Inside of this loop, X becomes every one of those one by one. So the first time it's 4, the next time it's Joe, the next time it's 3.14, the next time it's true. And for each one of those, I'm gonna print it out. So notice every time I just do print X, but I print out different things. And that's because of my for loop. The for loop automatically assigns a value to X every time it goes through. And it stops when you don't have any more elements, right? There was another way that we talked about for loops, and that was the range function. So let me add a code here. So we could say for X in range, and you put a number. I'm still going to print X. And here, the range function was something that's very useful for loops. The range function, you can think of it, generates a list of numbers automatically. So when you say like range 10, it basically generates a list of numbers from 0 to 10 and increasing by 1 every time. However, just like when you do slicing, you do include the start, you do include 0, but you go up to, but not including 10. So it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is actually useful because even though it doesn't include the number 10, there are 10 different numbers here because you start at 0, right? And so you can change this to whatever you want. You can do range 5 and it just print 0 to 4. you can do range 100, and this would print 100 numbers, right? So range is kind of just like a trick to basically get a list of numbers automatically. And in this way, there's another way to loop through the list like this. So here we say for X in range, len my collection. So really quickly, what is len my collection going to return? What is len my collection? Then I'm looking for a number.
4 or 3?
Yeah, it's 4. Yeah, so I understand why it could be 3 or 4. So 3 is the last index, that's correct. But the len returns the length, which is just the number of elements. And so here it's going to return 4. So here, this len my collection is going to be 4. So really what we have here is range 4. Range 4 is going to generate a list of numbers starting at 0, going up to 4, but not including it. So it's going to go 0, 1, 2, 3. And so in this loop, X goes from 0 to 3, one by one. And so here, we're using X as an index, right? X is not the element in the list, but it's what we use to access the list. We want to get the thing at element 0, the thing at element 1, the thing at element 2, the thing at element 3, right? And so here we can say print my collection, and we index into the list using X, right? And here you can maybe appreciate a little bit how things work together. Because len is not inclusive for the ending term, ending number, it works very nicely here. You just go up to the length of my collection, right? You can nest them. There's no -1, there's no +1. It just all works out. But I did promise that we would talk about while loops. So while loops, you can do the same task, printing out every element in the list, using a while loop as well. And so if we look at what a while loop is like, oops, wrong slides. This is what a while loop looks like. So this is the loop itself. There's some similarities. You have a colon, and then the body of the loop, which is all indented. So that's very similar. But the difference is the line up top. Instead of saying for, you say while, because it's a while loop. And for while loops, you have a condition. This is a Boolean condition. It will evaluate to true or false. And this is the condition on whether to keep looping or to stop. As long as the condition is true, you're going to keep looping. As soon as the condition is false, you're going to stop. Right? So here it's saying while count is less than 5. So if count is 3, if count is 0, if count is -10, this is going to loop. But as soon as count is 5 or larger, it's going to stop. So here, if we step through this, count starts out as 0. We say while count is less than 5, well, clearly 0 is less than 5, so we're going to loop. We print out 0, we increase it by 1, and we check again. Is 1 less than 5? Clearly. So we print 1, we increase it to 2. Is 2 less than 5? Yes, so on, until count is 4. 4 is less than 5. We print it, we increase count by 1, and then we check again, is 5 less than 5? But no, it's not. So then we stop, right? So this is another way of doing a loop. And so if we wanted to use a while loop to print out the elements of the list, we could say something like a variable to keep track of the index. It starts at 0. And then we say while the index is less than what? I want some help here. I'll finish the body. What is our condition here? What do we want index to be less than for us to keep going? Len, yeah. We want index to be less than the length. Notice this is a strict inequality. We want it to be strictly less than. It can't be equal, right? Because a list of length 3 only goes up to index 2. It's always less. So if we say index less than the len of my collection, want to do this, and if we run this code, oh, I didn't run the code above to do this. So if we run the code again, you can see this does what we wanted again. And here, notice I could have said a number here. We know that the length of the list is 4. So I could have just put 4 here while index is less than 4. But this is a little bit nicer because if we happen to choose to add elements to our list later on, our code would still work. It would still print out every single element. If we decided to remove elements from our list, it wouldn't care because it changes based on how large the list is. It doesn't matter how big it is. So this is a little bit better than hard coding a number. That's really all there is to while loops. While loops, I think, maybe make a little bit more sense when you're reading it in English, because if you just read the line, it makes sense. While the index is less than the length, okay? Loop. Sometimes you have to be careful about this. Sometimes you want less than, sometimes you want less than or equal to. That's the only tricky thing with while loops, really. While loops are really good if you don't really know how long you need to loop for, right? For loops are really like loop a certain amount of times, especially when you're using them with range, right? If you say for x in range 10, it always goes 10 times. But while loops are useful when you just want to keep looping until some sort of condition is met. Maybe you're asking the user to type in a number, and until they type in a number, you want to keep asking them. So it could take 0 times, or it could take 1 time, it could take 10 times, it could take 100 times. You don't really know ahead of time. So you can't do like a for range loop, but you can do a while loop in that case. So they are equally powerful. Everything you can do with a for loop, you can do with a while. Everything you can do with a while, you can do with a for. But sometimes one is easier to use than the other. Yeah. That's really it. One small comment is that for while loops, you can get what are known as infinite loops. And that's just a while loop where the condition is always true. So here, if we look at this code, it's very similar to what we saw on the previous slide, but it's missing one important line. It's missing the line where we say count plus equals 1, right? So if we look at this code, it almost looks right, but if we actually think about it, count starts at 0, we print out count, and then we check the condition again immediately. Well, we never changed count, so count is still 0. So then we print and we check the condition. It goes on forever because we never update count. Count is always 0, and 0 is always less than 5. That's not going to change. So this is just going to go forever. It's never going to stop. I can show you what it looks like on Colab if you do something like that. Say like while, I'll make count equals 0, and while count is less than 5, print count. If I run this, I have to be careful. I want to stop it very soon. You'll notice it prints out like a bunch of zeros, right? It's less because I stopped it a little bit, but there's a giant list of zeros right here. I can scroll through all of these. And this is because we had an infinite loop, right? It never really stopped. It only stops because I interrupted the program in the middle. And so in general, infinite loops, you typically never want them in your code because you never want code to run forever. But it's not really a problem either. Like you don't have to worry about your computer blowing up if you have an infinite loop. You don't have to worry about anything like going horribly wrong that's gonna mess things up forever. It's just a little bit annoying. You sometimes have to stop it and you have to restart things a little bit. Not your computer, but like your program, you have to restart it. but your computer is really all fine. There is one last thing I want to talk about for loops. And that's one way of controlling when to stop a loop. And so you can stop loops like kind of manually. There's a couple of commands that control how a loop runs. So the first is the break statement. So this one is really powerful. When you say break and when it's run, it stops the loop, no matter what. Yeah, that's one way of stopping it. But here's a little bit nicer way. You can call a break statement. And so if we look at this code, the loop says for n in range 2, 10. And so what's going on here is when we give it two numbers, the first one is where we start, the second one is where we end. So we're going from 2 to 10. And here is saying if n mod 4 equals 0, we break. We do a print statement and then we break. But what happens here is this is checking if n divided by 4 has a remainder of 0, right? Mod is just remainder. So if we're checking if the remainder is 0. If it is, we print and we break. And so this means when we go from 2 to 10, obviously when we reach 4, 4 mod 4 is 0. There's no remainder, right? And so you do the print and you stop. You don't go past 4. You don't, 8 mod 4 is also 0, but you don't get there because you stopped, you broke. So break exits the loop. A very similar kind of statement is the continue statement. And so the continue statement is a little bit trickier, in my opinion. So the continue statement also affects how loops run, but it's a little bit like less severe than break. Break will stop your loop. It prevents anything from happening afterwards in your loop. Continue, on the other hand, just says, hey, if you reach the continue, skip whatever's left in this iteration. Right? So if you have a loop that runs 10 times and each of those times it does some sort of code, if you reach the continue, it skips the rest of the code for that loop time only, for that iteration only. It'll still do the rest of the loops later on, but it just skips a little bit of code. So here, it's the same condition as before. If n mod 4 equals 0, basically if it's divisible by 4, we do this print and then we continue. When we continue, we skip everything afterwards, but we go to the start of the loop again. We go to the next one, the next step. So if we continue, we skip the hello print statement. And so essentially what this loop does is if it's not divisible by 4, it prints hello. If it is, it prints this and skips the hello. And so break, continue, they're useful statements. You'll definitely use them a lot when you use loops. But you have to know which one to use when. Continue is used to skip a portion of the loop. Break is used to stop it entirely. All right, so that's pretty much all I wanted to talk about for loops. I don't know if anyone had any questions. I can run maybe these code examples on Colab for you to look at. And if you're interested, I can also put it into, I can also put it into the chat. So if I go to Colab, let me get rid of this infinite loop actually. So I'm going to make that loop not infinite so I don't have to scroll through all that. But if I put this one, you'll see that it says 4 equals 4. And then it prints the state. If I didn't have the break, Can anyone tell me how this would run differently? If I remove the break statement, would it be different? Or would it still be the same thing? So I'm gonna comment it out. So the hashtag, the number sign is the comment. Does anyone want to tell me how it'd be different? How would this run differently if I didn't have the break? Let me call on someone maybe. Oh, I see. So Derek, you said error. So a hint, it wouldn't error. It wouldn't give you red text and crash, but it would print something that doesn't really make sense. So it would do something that doesn't make sense, like, well, in the sense that it doesn't do what our program intended to do, but it would run. So if we think about this code, what the break did is it stops the loop. So when n was 4, we go into this condition because it's true, and then we stop. We don't continue on. But if we remove the break, that means we don't stop. So then n equals 5, n equals 6, n equals 7, n equals 8. So when n is 8, when we check this condition, 8 mod 4 is 0 because 8 is divisible by 4, right? And then we'd print 8 equals 4, which doesn't really make sense. And then we do 9, 10, or not 10, but yeah. So if I run this, it's going to print 8 equals 4, which is not correct, but it's not an error in the sense of a Python error. This is only because the break made it so that after we print the first one, we stop the loop. We don't check later numbers. So if I removed it, then that would stop the check from taking place. So I'm going to put it back in. And now the one with continue. I'm going to put it in chat, but I can also put it here. So, I see these quotation marks a little bit weird from copy paste. We run this. You'll see that here it says hello, hello, 4 and 4, hello, 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 8 and 4, hello. Code after the loop block is now executed. So basically, if it's divisible by 4, it prints out the different message right here and there. And otherwise, it prints out hello. So right, 2 is not divisible by 4, 3 is not divisible by 4, 4 is, 5 is not, 6 is not, 7 is not, 8 is, 9 is not, and then it stops. So I want to ask the same question. If I remove the continue, how would this loop be different? You don't have to tell me what the output would be, but just tell me how would it be different? And maybe, let's see, Evan, do you want to give it a shot? Do you want to tell me what would be different if I remove the continue statement here? If I commented it out?
If continue was removed, then I think it would probably just loop forever.
So good guess. It wouldn't loop forever, but do you remember what the continue statement does in general?
So basically, doesn't it repeat the loop?
sort of. It skips the remaining code, and then it will go to the next iteration, right? So this loop runs a bunch of times, right? Once for 2, once for 3, once for 4. What continue does is says, okay, this time is done. Ignore everything after me and just jump straight to the next loop. And so here, what's happening is that if n is divisible by 4, that's what this statement is checking for. If n is divisible by 4, we print the different message, the n and 4 message, and then we would have continued. What continue does is skip whatever's left, which is the hello, and go to the next loop. Oh, I see we just lost Evan. Hopefully he comes back. But anyways, if we remove the continue, if we got rid of it, what would happen is that it would just do the rest of the body. It would print the hello. So the difference here is that it will print an extra message or 2 extra messages. With the continue, it only prints this and doesn't print out the hello. But if we remove the continue, it would also print the hello. It would print this message and that message if it's divisible by 4. So here, it would be hello, hello, 4 and 4, hello, and then 3 more. So essentially there's going to be 4 hellos here instead of 3, right? Notice right now, there's 3 between the 4 and 4 and the 8 and 4. But if I remove the continue and run it, now there's 4 of them. That's because the continue, what it did is it skips the hello if it's divisible by 4. But if we remove the continue, it doesn't skip it anymore. It still runs it. So that's what continue does. All right, we're back to 3 when we put it back. All right. So that was a long review time, but that's fine. All right, great. We have everyone back again. So in the time I have left, no problem, Evan. I'm glad you made it back though. We just went over the hello, the loop, and basically what happened is that if we remove the continue, it doesn't skip the hello, print hello statement. And so it just prints more if we don't have the continue. So here we have 4 and 4, 8 and 4, and we have 3 hellos in the middle. If we remove the continue, you'll see now that there's 4 of them. That's because it will print both messages if we don't have the continue. But the last thing I want to talk about is exception handling. So we're moving on to kind of a new topic. We're leaving loops behind. One thing I want to make a comment of is that everything for the review from Python level 1, they're going to be useful for what we're going to talk about in Python level 2, but we're not going to talk more about them specifically, in the sense that I'm not going to give you more problems that, oh, write a loop to do this, but you might have situations where I have a problem and you might need to use a loop to solve it. You might need to use if statements. You might need to use both. But I'm not going to test you specifically on any of these topics, or we're going to move on to some more, in my opinion, higher level things, programming concepts. The first in that series is talking about exceptions in Python. So we kind of already saw exceptions. We saw when programs would error. We saw when if you wrote a bad program, it could crash. It could give you red underlines, say, hey, this line had an error, go fix it, right? That's called an exception in Python. And what we're going to learn is essentially how to deal with them, right? So far, the only way we know how to deal with it is just to fix the code, right? But there's other ways of handling exceptions. This is really important in like real world programs because, for example, if you're like using Chrome, which someone had to write code to make, or playing a game, whatever. If you do something that's like not really expected, your browser doesn't just like blow up. Your game doesn't just crash, or at least it shouldn't. Um, it will have some way of saying, hey, what you did is not okay. It's not, I don't allow you to do that. Try again, right? Try it differently. And so that's kind of what exception handling allows you to do. Instead of just blowing up if something goes wrong, you figure a way to kind of fix it in the program itself. Your program has a way of saying, hey, I'm trying to do this, and if it didn't work, I'm gonna maybe print a message or use a default value, something like that, right? And so before we get to that, we want to look at some code that causes errors, right? So this is some code that we had similar to stuff that we've done in Python level 1, where we get input. So if we take this, I think I have it here. So here, the code, it's just calling the input function and then putting that into the int function, which converts it to a number and prints out the number, right? So it says, please enter an integer. I can enter 7 and it prints out 7. I can run it again. I can print out 99 and it, oops, that's not what I wanted to run. I'm running this. I can print 99 and it does 99. I can also even do negative numbers, -7 or -4, and it does -4. But if I put something that's not a number, right? No one right now is stopping me from typing in whatever I want. What if I type in my name? So caps lock. What if I type in my name and hit enter? Then we get an error, right? We get a red text, and this is specifically called a value error. And Colab is nice. It tells you exactly, hey, line 2, this line, it's a value error, invalid literal for int with base 10 jack. Essentially, this is the type of error, the value error. And this is just a message kind of detailing what went wrong. You don't really have to understand this, but if you're interested, it's basically saying that this is not a valid input. Base 10 is the number system that we use, 10 digits. And it says, hey, jack is not a valid input for a base 10 number, right? It's not a number in base 10. So I can't convert it and I give an error. There's another error type. For example, if we have the list here and I have a simple loop that says for n and x, print 10 divided by n. So it's going to do 10 divided by 1, 10 divided by 4, 10 divided by 8. But then you'll notice in my list I have 0. So it's going to try to do 10 divided by 0, which if you know anything from math class, is not defined. You can't divide by 0. And so here we get another error. It did the first 4, no problem, right? It did the first 4, but once it gets to 0, it says, hey, you have a 0 division error. Again, it shows, hey, this is the line that the problem happened on. The type of error is a 0 division error. And the message is just very simply, you divide by 0. That's not allowed. And so the question now is, we have these programs, they give these errors, they give these exceptions, but how do we make it so that our program doesn't just crash? Maybe instead of crashing, we want it to say, hey, print a message, can't divide by 0, but then it continues on with the rest of the list, right? So right now, this program, once it gets to 0, it just stops. It doesn't do anything afterwards. Maybe we want it to keep going on, even after it hits a 0. And so that's what exception handling is all about. So the way we do exception handling is with what's called a try except statement. And so I think it makes a little bit of sense why it's called that. It's a try because there's some code that you want to try. It might cause an error, it might not, you don't know, but you're going to try it. And then you have the except statements, which essentially capture any errors, right? So if your program throws an error, creates an error, you have ways of catching it before it reaches somewhere it shouldn't. So here's an example of what exception handling looks like. So notice we have a while loop, and this might look a little bit scary. It says while true. And so if this might look a little bit weird because, well, does anyone want to tell me why this looks weird at first? Why does a while true loop give us a little bit of concern?
When it's not true, it will just cause an error. It will just stop.
Sort of. I think you're hitting on the right topic, but essentially, if we just had this would be an infinite loop because true is always true. So the condition here is just true. It's always true. So we have to be a bit careful here because we need some way of stopping the loop. And if you notice inside here, we do actually have a break statement, and that's what actually stops the while loop, right? If we didn't have a break, we'd do this forever. Okay, so I just wanted to make a note there. If we look inside, we have our try and our except. So the try and except statements, they're similar to like if and else. You have a colon and you have a block of code. So you say try, you have a colon, and the stuff that belongs to the try statement goes in an indent, one more indent, right? So we have one indent for the loop and then another indent for the try. And so here we're trying to say the same stuff as before. Please enter a number, convert it to an int, print it out. But now we have this except value error statement. So if you remember, the error that we got when we tried to convert something that's not a number is a value error. And so what this is saying is, hey, if you have a value error from the try statement, instead of crashing, instead of doing all that, just do this instead. Oops, that was not a valid number, try again. And notice it does this, and what's after the try? Nothing, so it goes back to the top of the loop, right? So essentially the way this loop works is that it does the try. If the try completely finishes, it reaches the break and the loop stops. But as long as there's an error, as long as this ran into some sort of issue, it jumps to the except, it prints out the message and then goes back to the top because we don't break anymore. That's an important thing to notice. When you have your try statement, it helps you handle errors, but once you have an error, you ignore everything else in the try. So if this line causes an error, you don't do the rest of it. You jump straight to the except statement. And I had a question, how do the indents work? So again, in Python, the way we show blocks, like lines of code belong together, is that they have the same indent level. So the indent is just like tabs, it's this white space. So notice here, to show that this code all belongs in the while loop, we have an indent on all these lines. They all start a little bit in, right? And then we have another one for the try because this code belongs to the try statement. So it belongs a little bit in from the left of this page, right? And then this is the last part of the try so that the code afterwards goes back to the previous level, right? So the indent level, how far the code is from the edge, determines how things are grouped together. Anything with the same indent level belongs in the same group, essentially. So this is one group. And then the try and the except are another group. And the while is another group because they all have different indent levels. And again, you do with the indent by the tab character, which is above your caps lock key on the left of the keyboard. So I think I have this code already here. If we run this code, what I do is a little bit different. I have a little bit more of an advanced example, but here we are doing a very similar thing. We're doing input, we're converting it to an int. And then instead of just printing out the number, I try to do 100 divided by x, right? And then I have except value error, it just says, oops, that was not a valid number, try again. But I also have except zero division error. Oh no, nothing worked, right? And so this brings us to another topic. The try except statements is, I like to think of it like the if, else if structure. You can have as many excepts as you want. And the excepts capture different things. So this one captures value errors. This one captures zero division errors. You can have another except for a different type of error, so on, so on, so on, right? And you can have as many of these as you want. You don't just need to have one. You do have to have at least one though. You can't have a try without an except because it wouldn't make sense. The except is the handling of the exception, right? And so if you don't have an except, then your code is no better than how it was before. If you don't have a way of handling the error, it's still just gonna, go back to the red text and crash, right? But here, if we run the code, notice it's asking me for a number. And so if I'm nice and I say something correct on the first try, let's just say 2, it's gonna do 100 divided by 2, it's gonna do 50, right? But what if I'm not so nice? It says enter a number, but I just refuse to. I wanna say my name again. This time, instead of crashing, notice it says, oops, that was not a valid number. Because what happened was it tries to do line 4 and it realizes, hey, I can't convert it to an int. So then it goes to the except statements and says, hey, I have a value error. This except statement catches value errors. So I'm gonna go in here. It goes in here, it prints out the statement, and then it continues on just like nothing ever happened. Right? And I can do this as much as I want. I can enter my last name. I can enter random stuff, and it'll just keep asking me. Right? That's the while true taking part, because it keeps looping. Unless I hit a break, it'll keep asking me. And so now I can say a number again. I can say 50, and then it'll stop. It'll print out 2. I can run the code again, and I can enter text, and then I can also enter 0, right? So if I enter 0, notice the message is different because it's a different except statement that's being run. It's not a value error this time. It's a zero division error. And so this time it prints out, oh no, nothing worked. Maybe my message should be a little bit more clear. Maybe it should have said, can't divide by 0, but that's just my print statement, not as important. But again, it keeps asking me. So I can go back to saying, I don't know, text again, doesn't work. I can enter 0 more times, doesn't work. And finally, let me just enter like 78 and it gives me that. So what if I type in a number with 0 in it? So do you mean like 0.5 or 50? 0.5. Okay, yeah. So 0.5, that's a good question. So let's try it. If we type in 0.5 or 0.6, the error message is a little bit misleading. It says that was not a valid number. Try again. But this tells us something. This tells us that if you enter a decimal like 0.6, it's a value error, right? Because it printed this message, we know that somewhere along this code, we had a value error and we printed this message. And essentially what happens is that here, the input, it gets 0.6. It can't convert 0.6 to an integer. What if I type in 60? Well, 60 is fine. 60 is fine because 60, it's perfectly fine to convert 60 into a number. It's perfectly fine to convert it to an integer. So this doesn't give any problems. And 100 divided by 60, that again has no problems. Perfectly fine. It's even a little bit smart. So like, even if you type in 0.60, it works. It does the same thing. It knows that any zeros in front of your number don't really mean anything. And so it just treats this just like normal 60. Essentially, these only run if an error happens. This only runs if there's a value error. This only happens if there's a zero division error. You might have known there's like index out of bounds errors. For example, if I have a list, let's say this, I have a list that's like 1, 2, 3. And clearly I can do like list 2, or no, I don't want to do that. That's an error. So this is called an index error. This is yet another type of error. This is a list index out of range because I'm trying to access index 3 when there's only up to index 2. Right? A lot of different statements in Python can throw errors. You can even throw errors yourself. The last thing I want to get to is, well, first, a recap of how this try except works. You have your try clause, and it has a bunch of statements that you're trying to run, right? And the code in there, maybe it throws an error, maybe it doesn't. Doesn't really matter. But as soon as it throws an error, it will try to look through the except statements. So if an exception occurs, the rest of the try is skipped. You don't run the rest of the try. Just because if something wrong happened, you can't guarantee that you're going to be able to run the rest of it. So you don't even try. So when an error happens, you jump straight to the except statements and you say, you look through them top down. Is this the error that happened? Yes, no. Is this the error that happened? Yes, no. Is this the error that happened? Yes, no. Once you find one that matches, then you go inside and do whatever it tells you to do. It's basically like a guidebook. It says, in case of emergency, do this, right? And one thing that's true is that if an exception happens, but you don't have an except statement that captures that specific type of error, it will still crash. And this is because if you don't tell Python how to handle the exception, it just handles it the only way it knows, which is to stop your program. Right? And your try statement can have a bunch of except statements. You can even have one except statement that captures multiple different types of errors. So you can have like this, and all you do is you put it in a tuple, you put it in parentheses, separated by commas. So this one captures runtime errors, type errors, and name errors. You don't have to know what all these are or how they happen, but if you happen to need to capture two different errors, you can do it like this. And finally, there is one thing that you can do. You can capture excepts. You can do an except statement that is just a wildcard except, which just means that it will capture any type of error at all. Doesn't matter if it's an index error, doesn't matter if it's a value error, doesn't matter if it's a name error, it will capture it. And this typically belongs at the end of your try except statements, just because, again, it checks in order. So if you put it at the top, it doesn't make sense because it will always go in there and it won't go into any of the other excepts. We saw a similar thing when we did that if, else if, else if, else if, else. You can't, the order matters because it checks it from top down. And so if you have one category that includes a category below it, then you're never going to reach that because you're always going to go into the top one. And so this should always go on the bottom. And in general, this isn't the best practice just because it's a little bit lazy. You don't have enough control. You don't know what happened. Because you're capturing everything, you don't really know what happened. And so it's a little bit harder to deal with the exception. So it's a little bit not good practice, but it's fine to use it in this class. I'm not gonna punish you if you do choose to do it this way. And so here's an example. I'm gonna leave this as the last slide. I know it's 4 o'clock. In terms of homework this week, I think I'm gonna postpone homework 1 week. You get a break because it is the first class. But next week, we're gonna finish up just a little bit more about exceptions and then move on. And then we'll have a homework next week for exception handling. So you can take this break a little bit easy. You can review some of the Python 1 if you feel like the 1 week gap kind of maybe you forgot some things. To encourage you to review. Again, Coding Bat I showed you last time. That's a good resource if you like. But that's all I have. Thank you for sticking with me. I know we had a small class today, but hopefully we'll have a bigger class next week.